It feels like we've hit this point with AI where it's less about just one smart system and more about uh, how different systems can actually work together.
Absolutely. It's moving beyond individual agents.
Yeah, like a whole network of AI collaborating,
Mm.
which brings us to some really interesting kind of hot off the press stuff from Google.
Right. As these AI models get more complex, relying on just one, even a powerful one, isn't always going to cut it. The real potential, I think, is getting them to coordinate to talk to each other seamlessly. And Google's latest announcements definitely lean into that.
Exactly. So today we're going to dive deep into one specific announcement from Google's April 2025 event, this new agent-to-agent protocol. A2A, they're calling it.
A2A sounds like
Yeah.
a foundational piece for that collaborative vision.
It does. We want to unpack what A2A actually is, how it works, where it might be used in the real world, and maybe compare it a bit to another concept floating around, the Model Context Protocol, or MCP.
Good plan. And to do that, we've looked at quite a range of things, technical papers on how agents communicate, industry news, Google's own announcements, of course.
Right, trying to get the full picture. So let's get started. The April 2025 event, Google Cloud Next 2025, primarily.
That was the main stage, yeah. Google Cloud Next. And it was pretty massive. Hundreds of sessions, big keynotes, lots of partners there. It really set the stage for where they see cloud and AI heading.
Sounds like a huge affair. What were the big themes coming out of it?
Well, the core stuff revolved around, pushing AI innovation, obviously, big advancements in their data cloud, modernizing infrastructure, security, always a big one, and improving Google Workspace, too. Cover the whole gamut, really.
Okay, the whole spectrum. But the announcement that really grabbed our attention and what we're focusing on is this agent-to-agent protocol, the A2A. It's pitched as a way for companies to handle these multi-agent setups, right?
Exactly. And what's really key about A2A, from Google's perspective anyway, is this idea of interoperability.
Hmm.
They're positioning it as like a universal translator for AI agents.
A universal translator.
Yeah, so agents can talk to each other even if they're built on different frameworks or use different underlying models. That's potentially huge for breaking down those AI silos we mentioned.
Okay, that makes sense.
And importantly, they didn't do this alone. They mentioned over 50 partners were involved in defining the protocol.
50. Wow. Who are we talking about?
Big names: Atlassian, LangChain, Salesforce, SAP, ServiceNow, a real cross-section of the industry. That kind of collaboration suggests, maybe a better chance of it actually being adopted widely, which is critical for any new standard.
That collaborative piece feels important. It's not just Google pushing their own thing. And they also launched something called the AI Agent Development Kit, ADK.
Yes, the ADK. That's the other side of the coin, really. It's an open source framework meant to make building these multi-agent systems much, much simpler.
Simpler how?
Well, their claim was pretty bold that you could build an agent in under 100 lines of code.
Under 100 lines. Seriously.
That's the claim. If it holds up, it could really lower the barrier for developers wanting to experiment with this stuff, make it more accessible.
Okay, that is a bold claim. So A2A for communication, ADK for building them easily. What else relevant came out of the event? Anything on the hardware or infrastructure side?
Oh, yeah. They announced their next-gen TPUs, Ironwood, the 7th generation. These are their custom chips, specifically tuned for AI inferencing. Reports suggest pretty big performance jumps.
More speed for running the models, always needed. Anything else on infrastructure?
Uh-huh. They launched a new Google Cloud Wide Area Network Cloud WAN. The goal there is better network performance, maybe lower costs for companies spread out geographically.
Okay.
And for companies needing more control or maybe running things on-prem, they announced Gemini models would be available through Google Distributed Cloud, GDC.
Right, so options for different deployment needs. It wasn't all just back-end stuff, though, was it? Workspace got some AI love, too.
Yeah, correct. A few new AI features there. Help me analyze in Sheets, a Docs audio overview feature, and something called workspace flows for automation, trying to weave AI into those everyday tools people use.
Makes sense. Embedding it right in the workflow. And for the serious AI developers, Vertex AI got updates, too.
It did, yeah. Enhancements to Vertex AI itself and also their agent space offering. Things like Chrome Enterprise integration, making agents easier to access,
Okay.
and also an agent gallery, like a store for pre-built agents, an agent designer for building them without code, and even specific pre-made agents like one for idea generation and another for deep research. They're really trying to build a whole toolkit.
It sounds like a full ecosystem play around these agents. Anything else for developers?
Yes, the Google Developer Program Enterprise offering, basically a way for teams within companies to securely try out Google Cloud and AI stuff aimed at boosting innovation. And circling back to the 80K quickly, they also mentioned an agent garden, like a collection of code samples and tools, and an AI agent marketplace inside the Google Cloud Marketplace. Again, reinforcing that ecosystem idea.
Okay, so a real flurry of activity, all pointing towards more agents, more connection between them. Let's really dig into A2A now. What's the fundamental problem it's trying to fix?
The core issue is agent isolation. You have all these different AI systems popping up, different teams, different tech stacks, different vendors even, and they mostly operate in their own little worlds.
Right, like silos. Yeah.
Exactly, silos. And that really limits what you can do. Complex tasks that need multiple steps or types of expertise become really hard to automate end to end if the agents involved can't talk to each other. It's like having specialists who speak different languages.
Okay, so A2A is the bridge, the common language.
That's the idea. Google Cloud is pushing it as an open standard, common set of rules, so these agents can cooperate. The big goals are boosting productivity, obviously, but also cutting down the cost and hassle of trying to stitch together all these separate AI systems.
And as you said, it's not just Google building this bridge.
Definitely not. That list of over 50 partners, Atlassian, LangChain, Salesforce, SAP, ServiceNow, and others, that shows there's real industry buy-in, or at least interest, in having a standard way for agents to connect.
So what are the nuts and bolts? What are the key features or benefits A2A offers?
Well, a big one is that it focuses on what the agent can do, its abilities, rather than needing them to share, say, the same memory or tools underneath.
Ah, so they can be pretty independent.
Right. They can cooperate without needing to be deeply integrated at a low level. It allows for more modularity. Another big loss is that it uses common web standards,
Like what?
HTTP, server-side events, SSE, and JSON RPC. These are technologies most web developers already know.
Okay, so easier adoption curve, less new stuff to learn.
Exactly. Makes it much less daunting to implement.
What about security? If agents are talking across systems, that seems critical.
Absolutely. And they say A2A has security built in from the start. It supports standard ways to check identity and permissions. So Agent A can verify it's actually talking to Agent B, and that Agent B has the right to ask for certain information or actions.
That's crucial. Good. What about tasks that take a while? Not everything is instant in the real world.
Yeah, good point. A2A is designed to handle long-running jobs, things that might take hours, maybe even days. It has ways to provide updates on the progress.
Okay, essential for business processes
Yeah.
and data types. Is it just text messages between agents?
No, it's more flexible than that. It supports text, of course, but also audio, video, and even interactive data, like if an agent needs to present a form for a user or another agent to fill out.
Versatile. Okay, so you mentioned earlier this other protocol, MCP Model Context Protocol. Google initially said A2A complements it, but you also noted some sources see overlap.
Right, that's an interesting point. The initial messaging was sort of A2A for agent-to-agent talk, MCP for giving an agent tools. But some analysis, like in one Hacker Noon article, suggests they actually overlap quite a bit in what they aim to do.
Yeah, so.
Both are fundamentally about helping developers build more complex AI apps by letting them use multiple agents or connect agents to various tools and data sources. They're both tackling that how do we orchestrate multiple AI components problem.
So the line isn't maybe as clear in practice.
It seems potentially blurry, yes. And currently, a limitation noted for both is the discovery part. How does an agent automatically find out about other agents or tools it could use?
Yeah.
That often still needs some manual setup in both cases.
Right, automatic discovery would be the next level. Any technical differences we should know about?
Well, as we said, A2A uses HTTP, JSON RPC, and server-side events. MCP, at least in some versions, also use SSE, but apparently moved towards something called streaming HQTP, maybe to overcome some perceived issues with SSE for certain interactions. So slight differences in the plumbing, but the high-level goal feels similar.
Okay, so if we had to summarize the intended difference, it's like MCP helps one agent get the tools and info it needs, while A2A helps multiple capable agents talk to each other.
That seems to be the conceptual distinction, yeah. MCP equips the agent, A2A connects equipped agents. But again, in practice, especially looking at the features, there seems to be a lot of overlap in the kinds of problems you could solve with either. It's definitely something to watch as both protocols evolve.
Fascinating. This whole area of agent communication feels very dynamic right now. Let's make A2A a bit more concrete. Can you walk us through some practical examples? Where would the learner, our audience, see this being useful?
Okay, sure. Imagine a sales rep using an AI assistant. The rep asks, is product X available, and can we deliver it by Friday? The sales agent might need to talk to another agent, maybe one that hooks into the inventory system to check stock. That's agent one.
Right.
Then once stock is confirmed, the sales agent needs to coordinate with yet another agent, one connected to the logistics or shipping system, to schedule the delivery. That's agent two.
Okay, two different systems, two agents.
Exactly. A2A would provide the standard language for the sales agent to query the inventory agent and then instruct the logistics agent, all seamlessly behind the scenes. The rep just gets the answer.
That definitely smooths things out. Okay, give us another one.
How about customer support? A customer chats with a frontline support bot, Agent 1. It handles common questions, gathers info. But then the issue gets complex, needs a specialist.
Happens all the time.
Right. So, using A2A, Agent 1 to package up the entire conversation history, the customer details, everything relevant, and hand it off neatly to a specialized back-end agent. Agent 2, maybe in a different department system. Agent 2 gets the full context instantly.
So no more. Can you please explain your problem all over again?
Hopefully not. It maintains that context across the handoff. Much better experience.
Definitely. One more use case.
Let's say finance, an expense reporting agent. Someone submits expenses from an international trip.
Okay, different currencies involved.
Precisely. The expense agent needs the correct exchange rate for the day the expense was incurred. So using A2A, it could automatically ping a dedicated currency conversion agent, get the accurate rate, and process the reimbursement correctly. Again, two specialized agents collaborating.
Yeah, you can see how connecting specialized agents makes the whole process smarter and more efficient. These are great examples. It really paints a picture of A2A's potential.
And it highlights that modular approach: build specialized agents that do one thing well, then connect them using a standard protocol like A2A.
Before we wrap up, it feels like we should touch on security a bit more. If all these agents are talking, security has to be fundamental, right? We can't just rely on securing the network connection.
That's a really crucial point, and it goes beyond just basic network encryption. Some foundational work, like research papers on agent communication languages, emphasizes that security needs to be considered at the language level itself.
Why at the language level?
Because the agents themselves need to reason about security. They need to decide, should I trust this message? Who is this agent claiming to be? Do they have permission to ask this? It's not just about the pipe being secure. The agents need intrinsic security logic. There's this concept of lazy authentication, where you only authenticate when necessary based on the request.
Okay, so the agents are active participants in the security process.
Exactly. Older concepts like KQML, the knowledge query manipulation language, thought about communication in layers, content, message, communication, and security, has to permeate those layers.
So what are the key security requirements when agents communicate?
The basics are pretty standard. Authentication, knowing who you're talking to, integrity, ensuring the message wasn't tampered with, privacy, protecting sensitive content.
Right.
But also things like detecting duplicates or replays of messages, preventing someone from sending the same valid request multiple times maliciously. Non-repudiation is important too, being able to prove who sent what message and when, and preventing message hijacking.
That's quite a list. How is this typically achieved?
Well, the technical underpinnings usually rely on standard cryptographic techniques, things like encryption keys, digital signatures. These form the basis for building secure agent communication architectures, sometimes distinguishing between basic security and enhanced models that add things like non-repudiation and replay protection. A2A seems to be building on these standard principles with its support for identity and permission checks.
Makes sense. Security has to be baked in, not bolted on later.
Absolutely critical for trust in these interconnected systems.
Well, this has been a really insightful look at Google's A2A protocol and the whole move towards more collaborative AI.
It really feels like a significant step. The potential for businesses, for developers to build these more integrated, smarter solutions is definitely there, making agents talk across different platforms. That could unlock a lot.
Absolutely. And it's clear this space is still evolving, with the A2A and MCP discussion and likely more developments to come. It's definitely an area to watch.
For sure. The standards are still being forged.
Which leaves us with a final thought for our listeners. As these AI agents become more common, more powerful, and crucially, more interconnected, what new possibilities, but also what new challenges pop up? Thinking about things like governance, ethics. What does collaboration even mean when it's between machines at this scale?
That's a deep question. Definitely something to mull over.
Indeed. Well, thank you for joining us and helping us unpack all of this today.
My pleasure. Always fascinating to explore where this technology is heading.
And thanks to all of you for tuning in to this deep dive. We hope you found it valuable. Stay tuned for more explorations of cutting-edge topics in our upcoming episodes.